in the second half of today's class, we're going to be reviewing modular arithmetic. In the first half of class, we sort of played around with some concepts of modular arithmetic. But of course, as mathematicians, all of these things have to be formalized, and you have to really understand what's going on. And in some sense, when we were doing tossing numbers, that was basically looking at all the multiples of the tossing number in your modular arithmetic, right? That's basically what we were doing, and just seeing what numbers could be multiples. And in today's class, we're going to go over and review some of the things that we already did. So general rules for modular arithmetic that you should know, as well as how you can apply them in some slightly more advanced ways, such as in computing powers. So I know like some people had issues with how do you compute powers that are too big for your calculator? And the answer to that question is it all depends on what kinds of all these rules we have at our disposal. And we're not going to learn all of them today. In fact, today we're only going to basically review the ones we've already sort of learned. And then after the midterm, I will start teaching you more rules that let you do more advanced things. Like we still haven't even touched on division. Division is super complicated, so we're not going to talk about that until next week. But yeah, so general rules for congruence classes. So basically, remember we had, when we were talking about modular arithmetic, you guys were all in a circle, which you guys were in a moment ago. And you might have something like a 0 here. Let's say, let me just do 3 to make it easier. So 0, 1, and 2. But then 0 is also labeled 3, it's also labeled 6, also labeled 9. And 1 is also labeled 4, 7, 10. 2 is also labeled 5, -1, 8, etc. right? So you have all these labels for the same number. And these create congruence classes of all the possible labels, right? So for example, and it's exactly when they differ by a multiple of your modulus, but the two numbers are equivalent. And so you sort of noticed this when you were tossing the beanbags around, right? So if your modulus was 7 and you tossed around 7 times, that's the same as tossing around 0 times. It's as if you didn't do anything. And so 7 is equivalent to 0. Or we have things like 2 is congruent to 7 mod 5, right? Because they differ by a multiple of 5. Oh, did I turn off some of the lights? Yes. Yep. Oh, no. No, wait. Wait, which light is that? Is that any better? I can try playing with the lights a little bit more, but I think, oh, why are these lights on? Are those? There's, nope. Okay, I think this is the best I can do. Sorry about that. Okay, but where was I? Yeah, so 2 is congruent to 7 mod 5, since 2 minus 7 is minus 5, or 7 minus 2 is 5. And you also have things like, but more importantly, it's not just congruent to the smallest numbers. 71 is also congruent to 51 mod 10. Because 71 minus 51 is equal to 20, which is a multiple of 10. So if you had a group of size 10 and you tossed the beanbag around 71 times, that would be the same as tossing around 51 times, which was also the same as tossing around just once. But sometimes it's useful to know that these equivalences go both ways. So it might seem silly to toss it around 51 times when you can just toss it around once, but sometimes that becomes useful. It especially becomes useful when you're tossing backwards. So negative numbers can become especially useful. So like if you have 10 people, tossing it forward 9 times is the same as tossing it backwards once. So, or like 10, let's see. For things like 9 is congruent to -1 mod 10. So that's often quite useful, that particular equivalence. And of course, in order to do this, there is an easy way to find the smallest positive label for a positive number that you're starting with, which is to find the remainder of a divided by n. So for example, 7 divided by 5 is equal to 1 remainder 2. And so 7 is congruent to 2 mod 5. 71 divided by 10 is equal to 7 remainder 1. And we also have 51 divided by 10 is equal to 5 remainder 1. And so therefore, you know that 71 is congruent to 1 mod 10, and 51 is congruent to 1 mod 10, which is another way. And so because of that, you also know that 51 is congruent to 71 mod 10. Okay, so well, that's the basic rules of modular arithmetic, which is really easy. Just as you go around the circle, well, going around the full circle is the same as not going anywhere at all, and so you can remove those or add those in. It's also important to realize that when you're starting with a negative number, you need to first add something to make it positive before you divide, or otherwise things might go wrong. Okay, what if n is larger than a? Oh, well, if n is larger than a, then you already have the smallest positive label. So let me write that down because that's a good question. If a is less than n, then a is already the smallest positive label. So for example, if you already had, well, 2 mod 7, that's already the smallest label for that. So there isn't a smaller one. Okay. So that's the basics. You guys should hopefully be familiar with that by now. But now, of course, instead of just doing single numbers, we want to keep on going and do addition, multiplication, and eventually powers. Let's remind ourselves about addition. So when you're taking a plus b mod n, you have 2 options. And these 2 options, so the first one, which you guys should hopefully already be familiar with, is you just add the 2 numbers in normal arithmetic and then divide to find the smallest positive label. So this is a fairly straightforward way of doing it. So for example, 76 plus 25 mod 7. Well, this is congruent to 101 mod 7. And then we take 101 and divide it by 7. And of course, you have a calculator, so it makes it easier. But for the record, every problem on the midterm you can do without a calculator. It just is a little bit harder, but it is doable. And like while I'm writing the answer keys, I'm writing it out without a calculator, just so that I'm sure that that's possible. That's 1, that's 7, so that's 31. So that's 4, 28, 3. So that's remainder 3. So this is congruent to 3 mod 7. Okay, so that's one way of doing it if your numbers aren't too big. And for addition, usually your numbers won't get that big. The other way of doing it is you can first replace the numbers with another number from the respective congruence class, and then add and then replace again. So for example, using the same example, 76 plus 25 mod 7. Well, what is 7 divided by 76 divided by 7? 76 divided by 7, so that's 10, so that's 76, remainder 6. And 25 divided by 7 is 3, remainder 4. So this is equivalent to 6 plus 4 mod 7, right? Because you can replace each of the individual things when you're doing addition or multiplication. Or, I mean, we haven't gotten to multiplication yet. But you can do that. And so this is equivalent to 10 mod 7. And this is equivalent to 3 mod 7. Which option should you do for the midterm? That is a very good question. You should do whichever option you feel works better for you. And sometimes one option will work better than the other. And it'll differ depending on the problem. That's one of the sort of choices that you have to make. Importantly, both options will get you the right answer, and you're allowed to use either of them. But just make sure that you show enough work to show that you're what you're doing. But yeah, and sort of the part of the point of mathematics is proving that you can get the same answer 2 different ways. And sometimes one way will be easier, and sometimes the other way will be easier, but the answers should be the same, unless you do something wrong, of course. I personally recommend that you do both options and check your work, because well, you want to get the right answer. So I'll be giving some partial credit on the exam, but if you get the wrong answer, I obviously can't give you full credit. And so one way of getting around that is if I give you 2 methods of solving a problem, if you just solve it both ways, well, and you hopefully get the same answer, then hopefully that means that you got it right. Oh, sometimes I write mod n inside of brackets, sometimes I don't. It's exactly the same thing. That's just me being lazy. Okay. What about multiplication in modular arithmetic? Well, you have the exact same 2 options. You can, yes, you can write either way on the exam, and that's fine. So one way of multiplying is you multiply the 2 numbers in normal arithmetic first, and then you divide to find the smallest positive label. So what do we mean by that? So for example, 76 times 25 mod 7. What is 76 times 25? So that's 0, that's 30 plus 35, 380, and that's 251, so 1900. Okay, so that is congruent to 1900 mod 7. Okay, and let's see, what is 1900 divided by 7? By 7, that's 2, 14, it's 50, so that's a 7, 49, 10, 173. So remainder 3. And so this is congruent to 3 mod 7. Okay, so that's one way of doing it. And if you have a calculator, that's good enough. You can do that. The other way is you can first replace the numbers with their congruence classes and then multiply and then replace again if necessary. And so this just makes all numbers smaller, which can make it easier. Like if I were doing this by hand, I would prefer not to multiply ginormous numbers, and I might prefer to make everything smaller first. So for example, 76 times 25 mod 7 is congruent to 6 times 4 mod 7. Because remember, we already computed that on the last slide, so I'm using the same numbers. And that is congruent to 24 mod 7. Well, what is 24 mod 7? Well, you can subtract by 7 times 3, which is 21. And so this is congruent to 3 mod 7. And so that also works. Because you can, when you're doing addition and multiplication, you can always replace a number by any other number in its equivalence class. So you can replace 76 by just 6, and you can replace 25 by just 4. And indeed, if you think about when you were doing tossing things around, you could replace things like, if you're in mod 7, you could replace tossing around 7 with just tossing around 0. As the same sort of idea. What if one of the multiples is divisible by the mod? Well, what happens if one of the multiples is divisible by the mod? What is that equivalent to? So if I have the number 10 in mod 5, what is that equivalent to? Oh yeah, 0. Yep, it's just 0. And you know this, right? Because like if you toss around a beanbag 10 times in a circle of 5, you just end up right back where you started. Importantly, there are sometimes several different ways of doing this. So for example, I could convert this to 6 and 4, but I could have also converted this to a -1 times 4 mod 7, right? Because 6 is equivalent to -1. And sometimes it's easier to multiply by -1 than it is to multiply by, well, 6. And so then this is equivalent to -4 mod 7. But of course, that's also equivalent to -4 plus 7, which is equivalent to 3 mod 7. So you have some choices, and that makes it hard because I'm not just giving you a single algorithm for you to follow. Instead, at each step, you have to make a choice about what you think the easiest way to solve the problem is. Importantly, though, for these particular problems, each of the methods should give you the same answer. And so you can try it several different ways and then make sure that you did it right. So if one of the numbers is a 0, will the final answer be 0? Well, if you're doing multiplication, then yes, the final answer will be 0 if you're multiplying by something that's equivalent to 0. One way to think about it is if you're tossing them, and in fact, you saw this. So when you're tossing numbers around the circle, let's say that you are in a circle of just 3 people and you're tossing around 6 times each time. So that's equivalent to just having 6. But then if you, however many times you do it, if you do it, toss it around in groups of 6, 10 times, that's 6 times 10. But because tossing around 6 times gives you 0, tossing around 6 times 10 times still gives you 0. Okay. And let me give a little bit more, and then we'll try some of these out, because of course, practice makes perfect. Or at least better, maybe not perfect. Okay, so now we've done all this. What about simple powers in modular arithmetic? So we'll be coming back to this later with much more advanced stuff, because it turns out there are lots more tricks you can do with powers. But for simple powers, there are sometimes you can just think of it as a product, and you can break it up into lots of pieces. So for example, let's say I had 2 to the 10 mod 7. So this is actually small enough that you could do it all in a calculator. So you could do this as this is equivalent to 1024 mod 7, which is divide that, 1024 divided by 7. That's 1, that's 7, that's 32, 4, 28, 44, 6, 42, 2, remainder 2. So this is equivalent to 2 mod 7. Okay, so that's one way you could do it. But sometimes these numbers get way too big and your calculator fails you. So what do you do when your calculator fails you? Oh, sorry. Well, one thing you could do is you could break this up into lots of different pieces. So notice that this is equivalent to 2 times 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 2. Wait, did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, no, that's 11. So 10 of them, right? So I could break it up into these different pieces. And then what I could ask is, well, if I broke it up into these pieces, what can I say about each of these pieces? Well, one thing you might notice is that if I take these 3 pieces together, what's that equal to? Yeah, so it's equal to 8. But what is 8 equivalent to in mod 7? Yep, this is equivalent to 1. And so because it's equivalent to 1, we'll notice that I have this group of 3, that's also 1, and this group of 3, that's also 1, and then I'm left with a 2. And so this is another way of writing this, is this is equivalent to 2 cubed, but 3 of them times 2, right? So that's the equivalent to 1 cubed times 2, which is of course equivalent to 2 mod 7. Okay, so sometimes you want to break it up in different ways. Now, I'm not going to tell, so sometimes it's hard to figure out what ways to break it up. And so this is slightly more advanced than most of the ones I'm going to give you. There's another way of figuring this out though, which is, let me do this in red. So let me give you a different example that's slightly easier. So what about 2 to the 16 mod 7? So this starts getting a bit more complicated because 2 to the 16 is 65,536, which is a lot bigger. And these numbers get bigger. Don't worry, you don't need to know that. But these numbers get bigger, and so it makes it harder. But what you can notice is that there are a couple of different ways you could do this. One is you could notice that this is equivalent to 2 cubed to the 5th times 2 to the 1. So this is also equivalent to 2 mod 7. Because 2 cubed is equal to 1. But you may not know that. Getting to 1 is one of the things we'll be learning later. So later, I will give you a general way of getting to 1, so you can just cancel out those powers. But even if you don't know that, there is another thing you can do, which is you can say, well, this is equivalent to 2 squared, 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 squared. Why is that true? Yes, exponent rules. So it turns out if you have 2 times 2 times 2 times 2, that's 16. So if I give you the number 16, you can break it up into 2 times 2 times 2 times 2. Wait, 2 times 2 times 2. Yeah, 2 times 2 times 2 times 2, which is exactly how you break down 16. Yes, when you multiply the powers, you get 16. But now what can you do? Well, now you can do this in pieces. So this is now equivalent to, well, what's 2 squared? Yeah, so that's 4. So you can replace this bit with the 4. And then you still have a squared, 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 right? But now what's 4 squared? Well, you can replace that, this entire bit, with 16, right? So that's 16. Oh, sorry, meant to do that in a different color. So that's 16 squared, squared, right? Okay, well, so far so good. But what is 16? So remember, we're working in mod 7. And so 16 is bigger than 7, so you might want a smaller number, right? Yeah, so it's 2 mod 7. So this is equivalent to, you can replace that 16 with just the 2. So then it's just, oh, sorry, let me put that in red. So that's a 2 squared squared. Okay, and hopefully you guys sort of see what I'm doing. I'm sort of breaking it up from the inside out. And this is, of course, equivalent to 4 squared, because, well, you have the 2 to the 2, which is 4, that's squared, which is equivalent to 16, which, as we already know, is equivalent to 2 mod 7. Can you also do 2 to the 8 plus 2 to the 8? So you have to be a little careful here. You could do 2 to the 8 times 2 to the 8. But 2 to the 8 plus 2 to the 8 is actually 2 to the 9. If you don't believe me, just check. So what is 2 to the 8? 2 to the 8 is equal to 256, right? I mean, it is, just for the record. So if you take 2 to the 8 plus 2 to the 8, so that's equal to 512, which is actually equal to 2 to the 9. So what you need to do is you need to do 2 to the 8 times 2 to the 8 instead. Okay? So be careful about addition and multiplication. And you just need to be really comfortable with all the exponent rules that we started doing in the very first week. Because if you get those wrong, then, well, things will mess up elsewhere. Okay, so having said all that, let's have y'all try it out. And those of you who already did the sort of problems I had at the end of lecture on Monday that I didn't get to, will have already seen some of these. But let's start with this one. And let me, oh, the chat's already zeroed out. So what is 637 times 437 mod 7? So what can you do? You could multiply them together and then divide by 7. I'm not going to do that by hand because that's really painful. If you have a calculator, it's slightly faster. But of course, another thing you could do is you could use the rules that we did and notice. So one thing I'm going to notice is this 637 divided by 7 is 9 P1 with no remainder. So what happens if, so someone asked earlier, what happens if your number is a multiple of the mod? Well, then it's just equivalent to 0. So this is 0 times 437 mod 7. I'm not even going to bother figuring out what 437 is. I mean, I could, but why bother when you already know that anything times 0 is just 0. So this is equivalent to 0 mod 7. Okay, so that was an easy warm-up. Let's do something slightly harder. So I'm zeroing it out again. May I suggest, actually, that instead of just using your calculator, try to stare at this and see if you can make use of some of the equivalence rules to figure this out instead. Obviously, I know you can punch this into a calculator and get the answer, but let's try doing it without doing that. So one thing you might notice is 507 is kind of close to 509. I'll leave you with that thought for a moment. Okay, so it looks like most of you have gotten it. So let's take a look at 507. Well, if I have a big ring of 507 students, and I toss around a beanbag 509 students, and toss around 507 times, what is that equal to? Is there an easier way of getting it to the same person than tossing around 507 times? Yeah, I can just toss it backwards 2 times. And so this is equivalent to -2 times 237, which is equivalent to, that's minus 474. But of course, I want to turn this into something positive, and so I can add 509 to that, and so that's equivalent to 35. Okay, so this is one of those problems that if I wanted to do this by hand, it would be really painful, except that I happen to know these equivalence rules. I can convert things into negatives as well. Let's zero that out again. And let's try another one. So what's 367 squared mod 369? Okay, so it looks like people are starting to get the hang of it. Yeah, you could multiply it out and then divide by 369, but that's kind of painful. So instead what we're going to do is we're going to take this and recognize that 367 is the same as minus 2. And this is minus 2 squared, which is equivalent to 4 mod 369. And let's do another one. Let's do 49. Oh, sorry, 7 to the 6 mod 51. Okay, so it looks like a couple people have started getting answers. Can someone put in chat how you got that answer? So is there some trick you can use, or did you just brute force it with your calculators? Oh, okay. You guys brute forced it with your calculators. Oh, okay. So someone did 7 squared to the cube. Okay, so I'm trying to illustrate that you don't always want to brute force it. This number is small enough, but there will be a problem on the midterm, which is too big for you to brute force with your calculators. So you should try to keep in mind these other ways of doing it. And so in particular, this is equivalent to 49 cubed mod 51, right? But now what is 49 equal to? 49 is minus 2. So this is equivalent to minus 8 mod 51, which is equivalent to 43. Okay, so you can break it up into these smaller pieces and then figure things out from there. Okay, don't worry. We'll see some more things that will be too big for you to use your calculators for. So I am going to force you to do it without using a calculator in a little bit. But yeah, so let's move on to the next slide. What about this? So let's start with something nice and easy. And I really want you to start thinking about ways of doing this without just resorting to your calculator immediately. Because I know these problems are easy enough that you can just brute force it on your calculator, but not all problems will be. So what's the trick to this one? Did you guys just brute force it on your calculators again, or did you do something a little bit more clever? Ah, yes, good. So someone did 3 plus 73. Yeah, so because this is mod 100, so you only need to look at the last two numbers. And so this entire thing is equivalent to 3 plus 74, which is equivalent to 77. And so yes, you could have typed all these numbers into your calculator, but you really didn't need to. Okay, let's do one that's slightly harder. What's 105 times 237 mod 7? Okay, I lied. This one isn't actually slightly harder because one of the things you'll notice is that 105 is a multiple of 7. And so this is equivalent to 0 times 237, which is just equivalent to 0. And let's do this next one. What about this? 4,502 squared mod 4,507. Yep, it's just 5 squared. So this is equivalent, or rather it's minus 5 squared, but this is equivalent to 25. Okay, great. So what about this one? Minus, let's see, 76 times 77 times 78 mod 79. Okay, it looks like we're pretty evenly divided between E and C. What answers are you getting for the people who got E? Ah, yes. So be careful when you're dealing with negative numbers because, well, they're negative and it's easy to forget your negative signs. So in this particular case, this is equivalent to minus 3 times minus 2 times minus 1. You have 3 minus signs, and so this is actually equivalent to minus 6, which is equivalent to 73. But yeah, so if you got 6, that means you forgot one of your minus signs, and so be careful about that since you get the wrong answer. Okay, so those are some of the basic ones, and all of these you could have just done with your calculator. Should we write? Oh yes, you should. For the purposes of the exam, you should write your numbers as the smallest positive number. And yes, sometimes that will be a bit of a pain because the negative numbers is easier, but you should always write it in the smallest positive number for the purposes of the exam. Okay. Now for the fun stuff. What is 3 to the 64 mod 78? I think I made this big enough that your calculators won't work. So, but I'm not actually sure. I don't actually know how big your calculators are. So I'm hoping I made it big enough. Don't worry. I made sure that the one on your midterm is too big, so you can't use your calculator for that one. At least I can't use my calculator for that one. I'll give you guys a little bit more time. I know some people are trickling in answers, but we'll work through this together in a moment. Okay, so it looks like about half the class has gotten it so far. So let's start by thinking about how we want to work it out. So one of the things you might notice is that 64 is a power of 2, which I chose because it makes life a little bit easier. And so what I'm going to do is there are a couple of ways you could write this out. One of them is you could write this out as 3 to the 2 to the 2 to the 2 to the 2 to the 2, 1, 2, 3, 4, 5 to the 2. Hopefully I had the right number of parentheses. So yes, you could write that out and then you solve it by going outward. Another way of doing this is I can, instead of writing it out in this format, I can just look at what the powers of 3 are, right? So notice that 3 to the 1 is equal to, or equivalent to 3, right? That's easy. So, and then 3 squared is equivalent to 9. But if you know 3 squared is equivalent to 9, then what is 3 to the 4th equivalent to? So now what I'm doing is I'm squaring 3 squared. And so this is the same as 9 squared. This is equivalent to 9 times 9, which is equivalent to 81. What's 81 equivalent to? 81 is just equivalent to 3 again. And then, so what's 3 to the 8? Well, 3 to the 8 is then going to be equivalent to 3 squared. So that's equivalent to 9. And then 3 to the 16 is only going to be equivalent to 9 times 9, which is equivalent to 81 again, which is equivalent to 3. 3 to the 32 is going to be equivalent to 9. And 3 to the 64 is then going to be equivalent to 3 again. Must be write it as the most simplified answer? Yes, you must. So if you write 81 on the exam, you will get marked off points. Okay, does anyone have questions about that? That seems, it seems like the confusion meter just jumped up super high. Okay. Great. So this is one of the reasons why I wanted to have the slide in here. So let me explain a couple different ways. So let's do the other way that we did earlier. So you notice that we can take this number here, and that's 9, right? So that's 9, which means that this number here is 81, right? But 81 is equivalent to 3. And so if we rewrite this, what you just end up with is 3, 2, 2, 2, 2. Okay, why is it 81? Oh, well, what's 9 times 9? So let me do this a slightly different way. So one way is you could expand out this way, and that'll get you the answer. Another way of doing this is if you look over here, 3 to the 1 is equal to 3, or equivalent to 3. 3 squared is equivalent to 9, right? I can rewrite 3 to the 4 as 3 squared times 3 squared, right? So think back to the power rules. Or there are several different ways of thinking about this. This is 3 squared times 3 squared, or this is 3 squared squared, right? So if this is 3 squared squared, then that's equivalent to 9 squared, which is equivalent to 81, which is equivalent to 3. Okay, so what I've just shown you is that in mod 78, 3 to the 4 is equivalent to 3. But then, why does 81 equal 3? Because 81 divided by 78 is 1, remainder 3. Right? So remember, since we're in mod 78, anything bigger than 78, you can just divide by 78 and look at the remainder. Okay, so now what we've shown so far is that 3 to the 4 is equivalent to 3. Okay? Is everyone fine with that? So far, 3 to the 4 is equivalent to 3. If anyone does not understand that, please post that in the chat right now, because that's what we're building off of. No, you do not understand. Okay. Let me do it a different way, which is that instead of doing this weird doubling, what is 3 to the 4? You can do this in your calculator, right? 3 to the 4 is just equal to 81, or in ordinary math. Right? So that's just equal to 81 in ordinary math, which means that this is equivalent to 3 in mod 78. Okay? So this is equivalent to 3 in mod 78. And then we have 3 to the 8. But 3 to the 8 is, of course, just equal to 3 to the 4th squared, right? So one way of doing this is to then do the sort of ugly thing of doing 81 squared, and that's going to be some horrendously big number, right? But another way of doing this is you can replace 3 to the 4 with 3. So this is also equivalent to 3 squared. which is an equivalent to 9. Why do you only go up to 81? So because, remember, anytime you go over 78, you can reduce it to get a smaller number. And basically what we're doing is, if you wanted to, and you had a big enough calculator, you could do all of this by just taking 3 to the 64, and it'd be some ginormous number. So every time you go over the mod, if you want, you can make it smaller. And so remember, when we were looking at the other examples, let me go back to it. So remember, whenever you're just multiplying, you have a choice, right? You can either make everything smaller first and then multiply, or you can multiply and then make everything smaller. And so all we're doing is we're saying, well, the problem is our numbers are way too big, and so we have to make everything smaller many times, right? So each time we do a multiplication, you can make things smaller, and that makes life easier for the next multiplication. So you can go over the mod, but just remember that whenever you go over the mod, it's often easier if you make it smaller. And that's what we're doing here. And so on. And so then you get 3 to the 8 is equivalent to 9, and you continue this pattern. So you keep on breaking it up. Would 3 to the 8 times 8 work? So let me write that separately. So I guess the question is 3 to the 8 times 8. So what you could do is, well, this is equivalent to 3 to the 8 to the 8th power, right? And so if you knew what 3 to the 8 was, which is equal to 9, you could say this is equal to 9 to the 8. But then, of course, then you need to compute 9 to the 8. But yes, that would work. Eventually, you'd find that this is equal to, well, hopefully you find that it's equal to 3, but I don't have it quite computed out. Okay, let's try another one. So hopefully you guys have a sense of what's going on here. I know it's confusing. This is one of the harder concepts that we're going to be discussing in this class, which is this equivalence. So somehow when you were in grade school, you learned that a number is a number, right? And then you had lots of numbers and they were all different. The key here is that you only have 78 different numbers, and any bigger number is just equal to or equivalent to one of the smaller numbers. And so you can always replace it with a smaller thing because small numbers are easier to work with. Okay, so let's try 3 to the 64 mod 25 instead. Really, the key point I've been trying to illustrate, both with the earlier today's exercise as well as right now, is that when you're working in modular arithmetic, all these big numbers are just labels for smaller numbers, and you can say that they're equivalent. In mod 10, 10 is equivalent to 0, 100 is equivalent to 0, 1,000 is equivalent to 0, and so on. So let me zero that out before you guys start replying. So be careful about what you're doing, because remember, you have to divide out by 25 instead this time. And we'll work through this together, and hopefully I didn't make a mistake. So I don't think it's 2, but maybe I made a mistake. So we'll work this through together and see if I made a mistake. Because I also make mistakes, as you can tell from some of the solutions guides I've written. Uh-oh. I am somewhat concerned that so many people are getting 2. I'm also somewhat concerned that so many people are getting 3, because neither of those are the answers I got. So, well. Okay, well, let's work this through together since something clearly went wrong. Maybe I did it wrong, but it's quite possible. When the entire class gets a different answer than I do, that usually means I made a mistake. But let's work this through together, step by step. So let's start with the easier one, easiest thing. 3 to the 1 is equivalent to 3, right? Okay, hopefully everyone is on board with me on there. So then 3 squared is equivalent to 9, right? So far, so good. Then 3 to the 4th is equivalent to 9 squared, which is equivalent to 81, right? What is 81 equivalent to? Okay, so that's equivalent to 6. Okay, so far so good. So then we know 3 to the 8 is equivalent to 3 to the 4 times 3 to the 4, right? Oh, you could do 3 to the 3 as well. So there are several, I'll do this several different ways. But I'm going to do this repeated doubling way because sometimes I find that easier. So 3, but I'm skipping 3 because I want to skip numbers. So I don't want to do all 64 of them. So now 3 to the 8 is 3 to the 4 times 3 to the 4, right? So what's that equal to? So 3 to the 4 times 3 to the 4 is going to be equal to 6 times 6, right? Which is equivalent to 36, which is equivalent to 11, right? So hopefully everyone agrees with me that 3 to the 8 is equivalent to 11. So 3 to the 8 is equivalent to 11. So what's 3 to the 16? So 3 to the 16, where did the 6 come from? The 6 came from the fact that 3 to the 4 is equivalent to 6. And so you could replace the 3 to the 4 with a 6. And now we have 3 to the 8 is 11, right? So 3 to the 8 is equal to 11. So what's 3 to the 16? Well, that's 3 to the 8 times 3 to the 8, right? Oh, yeah, because 81 minus 25, 81 divided by 25 is equal to 3 remainder 6. 81 divided by 25 is equal to 3, that's 75, 6 remainder 6. Yeah, so you just mod 25 everything. That's basically what I'm trying to say, is that at any point you can do mod 25 and make things smaller. And that often makes these computations easier because all your computations are then within some small range. But yeah, so where were we? We were doing 3 to the 8 times 3 to the 8. Well, that's just 11 times 11, right? So that's 11 times 11 because that was from 3 to the 8 is equal to 11. So that's equivalent to 121. So what's 121 equivalent to? Yeah, it's just 21, right? Because 121 divided by 25 is 4 times 125 is 100, 21 remainder 21. Okay, well, let's keep on going. So now we're at 3 to the 16. Then we can do 3 to the 32. 3 to the 32. Oh, on your scratch work, I won't mind if you don't put mod everywhere. So on your scratch work, you can just do what I'm doing and just write the triple equal sign. I mean, strictly speaking, you do need a mod there, but if you're just doing scratch work, I'm not going to require it. I don't usually write it down. So 3 to the 32, well, that's going to be equal to what? 21 times 21, right? Well, what's 21 times 21 equal to? So that should be equal to 441. So you can multiply that out on your calculators. And that's equivalent to, what is that equivalent to in mod 25? Okay, so that's equivalent to 16. You can do C list by just dividing out. So then 3 to the 64 is equivalent to 16 times 16, right? Which is equivalent to 256. And 256, I think, is equivalent to 6. So I thought the answer was 6, and hopefully that is correct. I know some people got different answers, but we should all make sure that you guys all agree with me on my logic. And it's quite possible I'm wrong here. I hope I'm not, but let's work it out a different way just to make sure I'm not wrong. So someone wanted me to do it by 3 to the 3. So let's do it that way instead. So you notice that 3 to the 3 is equivalent to 27, right? Which is equivalent to 2. Okay, so then I could do something like then 3 to the 6 is equivalent to 2 squared, which is equivalent to 4, right? Because I'm again doubling. So I'm taking a square. So then 3 to the 12 is equivalent to 4 squared, which is equivalent to 16. Then 3 to the 24 is equivalent to 16 squared, which is equivalent to 6, right? And then 3 to the 48 is equivalent to 6 squared, which is equivalent to 36, which is equivalent to 11. But now it's slightly harder because I can't just do a doubling. So how many more copies of this do I need? I need another 16 copies, right? Is that right? 64 minus 48 is equivalent to 14 minus 8, that's 6. 16, right? So remember, we have this fact here, 3 to the 16 is equal to 21. And so this is going to be slightly complicated, which is why I will suggest doing doubling as your initial guess. But so 3 to the 64 is equivalent to 3 to the 48 times 3 to the 16, right? Hopefully everyone agrees with me on that. If not, hopefully I didn't do something wrong. So then that's equivalent to 11, because that's 3 to the 48, times 21. 21. Which is equivalent to 232. Wait, what? No, 231. Yeah. 231. And what's 231 equivalent to? So this is equivalent to 6. And so you get the same answer if you do it this other way. I will go ahead and tell you that for the purposes of the midterm, this repeated doubling will work. So I will go ahead and tell you that just because we're going to spend some more time on more advanced powers next week. But like for this initial stuff, the just repeated doubling will work. I've already made the midterm. I just need to get it printed and all that. So yeah. Okay. It looks like we are just about out of time. So I will go ahead and end class there. But I should announce that, where did I put that thing? Oh. There is a practice midterm. Hopefully you guys have all seen it. There is also an answer key that I put on Quercus. So you guys should hopefully have both the practice midterm and the answer key. And you should look to see how I filled it out, because importantly, you write your student ID and in both places. Make sure you write your student ID in both places, or I will be somewhat irritated because I'll have to manually match your exams. Yeah, there were some other questions about, yes, you still do have tutorials on Friday. It will be exam review because you guys wouldn't pay any attention if it weren't exam review. So all the tutorials this week are just basically exam review. In terms of during the midterm, are you allowed to bring a blank piece of paper with us? So I would prefer that you have all your work on the pages, because any scratch work will not be graded. And so I prefer if you write everything down on the pages themselves. I will try to have enough space on the pages for you to write them down. If you absolutely do need scratch paper, I will have scratch paper. But just keep in mind that anything you write on scratch paper will not be graded. In terms of exam logistics, try to come a little bit before. I sent out the notes earlier about what to bring. Oh, this is very important. You should not have your cell phone by your desk during the exam. So often what people do is they'll put their backpack with all their stuff near the front of the room. Make sure you turn it on silent because it would be a pain if it went off during the exam. But do not have your phones at your desk. That is considered an academic offense. So please just don't do it and keep that in mind. I do have office hours now. So if anyone wants to come and talk, I'll be walking back over to my office. If no one comes down, then yeah. So anyway, good luck on Friday. I will see you then. Bye, everyone.